So in our example, we'll be applying an example of how linear algebra is used in economics. And basically, the linear algebra is mainly used in modeling input-output economics, also known as the Leontief input-output model. And it's the basis for more complicated models that's used like all over the world in governments and things like that. The equation right here is one that we'll be using, and it's amount produced, which is X, equals intermediate demand plus final demand, D. And the amount produced, which is X, is the production vector in Rn that tells the output of each sector for 1 year. And D, final demand, is the values of goods and services demanded from the various sectors by the non-productive part of the economy. So this could be consumer demand, government consumption, surplus, exports, etc. And the sectors work together to meet the consumer demand, which will create the intermediate demand. And the sectors that we're going to be using are manufacturing, agriculture, and services. And basically, this model is important because it helps estimate the needs for goods in the future, as well as tracking change to domestic production and foreign trade. In the United States, many improvements in technology, prices, wage, and rates of return of capital have been made just from using this model. And basically, the Leontief model allows the government to make improvements to policy changes in an effort to better their nation and the world economies.
Okay, so the first part of our question is asking what amounts will be consumed by the agriculture sector if it produces 50 units. So we're going to start out by multiplying 50 times the agriculture matrix, which will be 0.6, 0.1, and 0.3. So that tells us that you'll consume 30 units for manufacturing, 5 units for agriculture, and 15 units for services.
All right. For part 2 of our problem, it's suppose the final demand is 60 units for manufacturing, 40 units for agriculture, and 30 units for services. We now need to find the production level X that will satisfy this demand. To do that, we're going to use the production equation, which is I minus C times X equals D to find the final demand. And so currently we're going to subtract the coefficient matrix from the identity matrix to get us our final demand.
Part 3 of this problem builds off of part 2, where we found the matrix from taking the identity and subtracting the coefficient matrix. We are then going to solve for D, which is our final demand, which is 60 units for manufacturing, 40 from agriculture, and 30 from services, in order to find how many units each different sector must produce to meet this demand.
So from this matrix to row reduce, you take row 1 and add 2 row 3, and you get this matrix. From this matrix, add 4R1 to row 2 and add 3R1 to R3, you get this matrix. Then take row 3 and subtract R2, get this matrix. Then take negative 1/2 of the third row, and you get this matrix. Then take row 1, subtract 14 R3, and row 2 and subtract 53 R3. you'll get this matrix. From there, take negative 1 over 39, multiply it by row 2. You get this matrix over here. Then we just need to get rid of that negative 12, so row 1 plus 12R2. You get the identity, which equals these 3 numbers, which equals this right here.
So in summation, we need 1,100 units of manufacturing, 750 units of agriculture, and 650 units of services in order to meet the demands of manufacturing, agriculture, and services.